Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarvatan. There is another question of titration. Student is given sample of an organic acid B and asked to determine its relative molecular mass. Suggest its molecular formula. Sample of the acid is placed in previously weighed container and reweighed. Mass of container plus V is equal to 8.38 gram. Mass of container is equal to 6.92. So calculate the mass of V. The mass of V is equal to 8.38 minus 6.92. So this is equal to 8.36 minus 6.92 equal to 1.44. This is 8.38 minus 6.92 is equal to 1.46. The student transfers the sample to a beaker and adds 50 centimeter cube of 1.00 mole per dm cube of sodium hydroxide and excess. The contents are allowed to react and are then transferred to a volumetric flask. The solution is made up to 250 centimeter cube with distilled water. This is solution W. 25 centimeter cube of W is transferred into a conical flask. A few drops of thymolphthalein indicator are added to the conical flask. Thymolphthalein is colorless in acidic solution and blue in alkaline solution. A 0.100 mole per dm cube hydrochloric acid is put into a burette and added to a solution in the conical flask. What is the color of the solution in the conical flask? So in the conical flask, sodium hydroxide is taken while hydrochloric acid is in burette. So the color is given in this statement that it is colorless in acidic solution and blue in alkaline. So what is the color of the solution in the conical flask? Before the acid is added, it is blue, and at the end of, because it is written over here, it is colorless, so blue to colorless. The student does 3 titrations. The diagram shows parts of the burette with the liquid levels at the beginning and the end of each titration. So these are 3 sets of titrations. Just fill the, so this is the final reading and this is initial. So please keep it in mind always. Just you have to fill final reading, second titration burette, and then in every set of reading. So final burette reading is 25.9. This is 25.9. This is 25.9 and initial reading is 25.9. Initial reading is 0.0. Second titration, the initial final reading is 48.6 and initial reading is 23.3. 25.3. 23.3 is so okay. And third set of reading from third titration is 32.4 and 7.123. 7.3. By subtracting 25.9 and this is 25.3 and this is 25.1. So best titration go with two smallest reading, the two closest reading. 25.1 is the smallest and nearest to the smallest is 25.3. There is little difference between the 25.1 and 25.3, so we have taken the two readings which have smaller difference. Use these results. The average volume of 0.25.3 plus 25.1 divided by 2, so this is 25.2. Calculate the number of moles of hydrochloric acid and the average volume of 0.100 mole per dm cube hydrochloric acid from C. So by using mole is equal to concentration into volume over 1000, because volume is taken in centimeter cube. So the concentration is 0.100 multiplied by 25.2 divided by 1000. The answer is 0.00252. The equation for the reaction between hydrochloric acid and sodium hydroxide is shown. HCl plus sodium hydroxide. Use the equation and your answer to D. Reduce the number of moles of sodium hydroxide in 25 centimeter cube. So by taking mole ratio, HCl ratio sodium hydroxide 1:1, and the mole of sodium hydroxide, the mole of hydrochloric acid is 0.0025. Using your answer from E, calculate the number of moles of sodium hydroxide in 250 centimeter cube of TBE. 25 centimeter cube containing 0.00252, while the what moles are present in 250 centimeter cube. So to cross multiply, the answer is 0.0252. Calculate the number of moles of sodium hydroxide in 50 centimeter cube of 1 mole per dm cube of sodium hydroxide. Mole is equal to concentration into volume over 1000. So concentration is equal to 1 mole per dm cube multiplied by 50 divided by 1000. So the answer is 0.05. By subtracting your answer in F from your answer in G, calculate the number of moles of sodium hydroxide that reacted with the original sample of the organic acid V. 0.05 minus 0.0252. The answer is 0.0248. 1 mole of V reacts with 2 moles of sodium hydroxide, 1:2 sodium hydroxide. Subtracting, calculate the number of moles of sodium hydroxide. So 1 mole react with 2 moles of sodium hydroxide, 0.0248 ratio X. The answer is 0.0124 moles are there. Using your answer from A and I, calculate the relative for molecular mass of the acid V. MR of acid V is equal to mass over mole. Mass from the first part 1.46. 1.46 divided by mole are 0.0124. The answer is 118. The acid V contains two carboxylic acid groups and has the molecular formula. This is the molecular formula HO. This is a 2 carboxylic acid and each carboxylic acid is MR of carboxylic acid 45. So where X and Y are whole number. So if we are taking CnH2n plus 90 is equal to 118. So 12n plus 2n is equal to 18 plus 90. 14n is equal to 28. So n is equal to 2. So CXHY, this is Cn is Cx or Hy. So if x is equal to 2, so Cn H2n mean 2 H2 multiplied by 2 is equal to 4. So y value is 4. So this is C2H4. This is C2H4 CO2H and HO2C. Give the ester produced when we react with two molecules of ethanol. So we have OOC C2H5, this is ethanol, and C2H4 we have, which we have calculated, and then CO2H COO C2H5. So this is the structure of ester. So how to draw it? Look at this. CO C double bond O C2H4 CO C2H5. So this is all about this question.